Okay, hello everyone and welcome to my video. In this video we'll be looking at finding unknown values using tangents. So to start off I want to read out the question, and the question says the tangent to the curve y equals x squared plus ax plus b, where a and b are constants, is given by 2x plus y equals 6 at the point where x equals 1. Hence, find the values of a and b. So first off, it's always good to write down the key information that we have from the question. So we also know we're working with a polynomial. That's the function that we're looking at the slope of the tangent of, and we've got a and b as constants that we need to find. And we know that when x equals 1, that the actual tangent function, or the equation of the tangent, is given by, and we've got the actual thing as being 2x plus y equals 6. Okay, so we've identified all our key ideas there. Just make that y look a bit more like a y. Okay, and what we first need to start off doing is trying to find the y coordinate, because we need a coordinate point in order to be able to work out what the values of a and b are. So in order to find the coordinate point, we just evaluate the equation of the tangent when x equals 1, because it's a nice and easy equation to work with. We know all the values, we can just plug in a 1 for x and then rearrange in order to find y. So yeah, what we're essentially looking at, if we think about it graphically, is we've got a convexing parabola and we've got a tangent x equals 1. So this is a shared coordinate point that we're trying to find here. And that shared coordinate point will allow us to identify values of a and b. So, if we substitute in 1 to our tangent function, we get 2 plus y equals 6. So therefore, y equals 6 take 2 equals 4. And we have that shared coordinate point, 1, 4. So x equals 1, y equals 4. And we've already made progress towards finding those values of a and b. That's an important piece of information we need to keep in mind. So now what we also want to do is, we want to consider what this actually tells us about our original function. Remember, that coordinate point is shared. So we can actually substitute in 4 and 1 and get some information about what an a and b equals. And this might be helpful later, so it's generally a good thing to do. Use the information you can find to its maximum potential in order to work out the unknown values. That's the key to solving these sorts of problems. So, when we substitute in, we get 4 equals 1 squared plus 1a plus b, and therefore we essentially get 4 equals 1 plus a plus b. And now we can just move that to the other side, so we get 4 take 1 equals a plus b, so we get 3 equals a plus b. And that's the next key bit of information. That's pretty easy to follow. Again, that coordinate point shared, so we're able to use that information with the coordinate to be able to work out that. So now what we do is we need to take the derivative, because again, that's the slope of the tangent. And we want to find the slope of the tangent in order to formulate the equation of the tangent. So when we have the equation of the tangent, we know that it's got to equal this, so we can work out those values of a and b accordingly. So again, it's going quite well so far. So what we want to do is we want to say, well, let's differentiate the original function to find the slope of the tangent. So we differentiate this function. So we've got x squared, so we move the 2 down to the front. So we've got 2x to the power of 1. So it's just 2x. 2x plus a, because of course, the coefficient of a number which is just x to the, a coefficient of a term which is just x to the power of 1 is of course just going to be that coefficient, and the derivative of a constant is 0, so we know that that is obviously going to be our derivative. So now what we can do is we can think, well, hang on a second, we're evaluating it when x equals 1. We're evaluating it when x equals 1, we know that, so we can simplify it down even further, because what we really want to find is the f prime of 1, if this was our function f of x, and what we're finding is f prime of 1. And so we end up with 2 plus a as being the slope of the tangent. 2 plus a. there. So what we can do is we can format this in the form of the equation of the tangent, the general form of equation of a tangent, and rearrange accordingly. So in order to do this, well, we have y, take the y coordinate, which we know is 4, so we end up with y take 4, on x take 1, because we know the x coordinate's 1, so it's always x take the x coordinate and y take the y coordinate, equals 2 plus a. Nice and simple there. And what we need to now work on is actually isolating y, or getting some sort of expression we can work with where it's in this form here. And again, we know from before that what this actually is rearranged to is y equals 6 take 2x. Again, because that's positive 2x, so we just move it to the other side, it's take 2x. So it's pretty good to try and work out, okay, I'm going to get it into this form, and then I can actually see by observation what the values of a and b must be. So we end up with y take 4 equals 2 plus a, lots of x take 1. Okay, and we expand that out. So when we expand it, we end up with y take 4 equals 2 plus a lots of x, take 2, take a. Hopefully you can see how I got that. It's pretty straightforward. And then what we actually get from this is we think, well, okay, we can move this 4 to the other side, and so we get y equals that. And let's simplify down the constants. That's probably the first step to do. So when we simplify down the constants, we have negative 2 plus 4, sorry, is going to make positive 2. So we can just simplify that down to positive 2. Take a. Okay, so what we now know is that 2 plus a lots of x plus 2 take a equals y. And when we compare it back to the function that was originally given, we know that y equals 6 take 2x. So therefore we can say, well, if this is positive 2 here and we're taking away a, we must be taking away negative 4, because again we want a to be equal to 6 based on this. We want the value of 2 and negative a to be equal 6. So we know that this here, because it's the part that is a constant, must equal 6, so therefore we can say, well, okay, we need 2 plus 4 essentially, and the only way we can get that is 2 take negative 4. So therefore we can actually say that a equals 4 because of that. And now what we can also look at is the value of b. So if a equals 4, or negative 4, sorry, then, again, it also fits in, so if we add 4 there, then it's 2 take 4, which is negative 2. Negative 2x is back there. But we also need to look at b, and again we can use this rule here. 3 equals a plus b, so therefore if we know that's negative 4, then b must hence be 7. And we've actually got both the value of a and b there just by using the actual previous statements that we've got there. So that's a quick look at finding unknown values using tangents. I hope the video was helpful and not too confusing. It's just about looking at the values of a and b and rearranging the equations and finding data from the equations that can be useful using the derivative and differential calculus laws you already know. So again, if you have any comments, post them below. But that's it for this video. Hope you enjoyed it. And remember to subscribe if you like maths.